So today we are going to discuss about the weather classifications from the data sets with different weather conditions, and we are going to develop a deep learning model, and we are going to train the model and testing, and we are going to evaluate the results using different matrices and curves. So before moving to our classification model, first we move into the discussions of our data set. So this data set contains 6 folders, 5 folders having each category with and there is another folder called alien test folder where we have our test data, and also we consist as with a CSV file, and also this data set have 5 major classes called cloudy, foggy, rainy, shine, and sunrise. So according to these major model, major classes, we are going to classify the weather according to the images, whether it is a cloudy, foggy, rainy, sunshine, or sunrise. So this is the basic idea about our data set. So I am using these data sets from the Kaggle, and from these data sets, I'm going to create my deep learning model. So for using this data, I'm not going to download the data and save it in my drive or saved temporarily in the Google Colab. Instead, what I'm going to do is I'm going to load the data using Kaggle API. So first we need to download the data from Kaggle. So I'm going to download download data from Kaggle API. So after downloading the data from the Kaggle API, we can set the multi-class weather data set, and we have to unzip the training data. So first we have to load the data. First we have to call the API, then we have to load certain specific URLs, and then after we have to unzip the training data. And then after unzipping the folder from these locations, we can see the data under the dataset folder. So in the dataset folder, we have cloudy, foggy, rainy, shine, and sunrise. And other than that, we have alien test. So this is the test data that I am going to check when the model is trained. And test CSV is the true labels for that one. So before moving to the classifications, we have to arrange the data. So read the data sets and see the folders and files available here by these functions. So after seeing the folders and the files available in this collab, what I'm going to do is we have to split the data. So split the data into training and validations. So I created new folder called weather data. Under that, I am going to divide it into the content under the content directory. So then after under the weather data, I created two folder called train and validations, and it has 5 subfolders. So train and validations, and each have the different 5 subfolders according to the as we know, we have 5 major classes, so we have the 5 subfolders. And then we can see the distribution. So until now, we have the download data and split the data, and we have stored in some sort of the directory. So before moving to the model creations, we have to make sure of our distributions of the data. So we can make the distributions of the class by the graph, and even we can able to view the number of images in each classes. So similarly, we can view the training data sets as well as validations data sets. So these are the very basic things that we have to do before moving to the model creations. And one more thing we have to do is the data augmentation. So to create deep learning model, we have to import few libraries. Here I import optimizers Adam, and pre-processing image data generators, and for the layers, what I'm going to build in the model creation. So I import conversion 2D, max pooling, flatten, dense, and if I need dropout, I already import dropout in my collab. As well as and also I need to make sure that my model callbacks stopping at the early stopping, and model checkpoint means it saved the best model with the best weights. So, and also we have to provide the regular input as an input size. So image width, height, and the batch size. So for that, I choose image width as the 256 and height as the 256 and the batch size as the 60. Now I import the libraries that we need for the data augmentations and then other sort of things. And also I created the input size of the image. Now we told our training directory as train folder and ready to do data augmentations. Why we need data augmentations? We have less data and need to augment it more. So we have less data, but we have to augment it to more. So for that, we have to do some sort of data augmentation. So first we have to rotating. When take image, we rotate by 30 degree and zoom the image by the 0.4 ratios, and horizontal flip means we are rotate the image by 90 degree. So we created generator functions, and it picked from the training directory of the batch size as the batch size we created the variables, and it has maintained the class mode as the categorical mode as we have the multi-class classification. So for the validations, we just did rescaling because we need to make sure that the model is going to work very. Uh, we have to see them how the model is going to work. So in the validation steps, we don't need to focus more on the data augmentations. And then after we call early stopping and we monitor the validation logs, and if we found the best models, we want to save it. So that's the things that we are going to do by these ones. And after that, we are going to consider the model with the sequential. So here our base layers have the input 16 filter 3 by 3 size and applying the relook functions. And the first layer rearrange the image, and we have three because as it is a Kyle image, and after all these layers we have to flatten, and we have created fully connected neural networks because these are the things the feature is learning, and the last layer we have to give the results, and we have to maintain the 5 because we have the major 5 classes, and as we have the multi-class classifications, as usual we maintain the softmax as the classification for the classification activation functions. So now we can see as a summary the total number of parameters, the number of trainable parameters and non-trainable parameters, what we created in our training model. After that, we are going to compile our model using our optimizer called Adam, loss called categorical cross entropy, and matrix called accuracy. And we are going to train our model with the epochs of 50 with the validations data fit with the validations generate. So we are going to train our models with the 50 epochs, and we could able to see that the accuracy loss, there will be a little change in each epochs after, specifically when we consider the epochs. There is a huge improvement after 33 epochs years, and there is another improvement in the 36th epochs. Yes, and after that 42, 40 epochs, and 43, 44, even be able to get the 80. So it makes sense to make the epochs, and to confirm further, we can make it as a valid graph. So one thing is we have to see that we don't have any overfitting here because of the validations and the loss, training and validation's accuracy is overlap going in the smooth way. There is no, one the best performance of this model is there is no overfit. And when we see about our epochs with the training validation loss, also graph is even though it has ups and downs, it goes with a decreasing manner or increasing manner. So, and after that, what we are going to do is we have to test the performance on the test data. As we all know, even though we train the models with our training data sets, we have to make sure our models with the test data. So for that, we are going to test the performance on the test data, and we are going to have that images loaded into the we have the images from the data sets. As we already mentioned, there is another folder called alien test that have test data of each classes have 6 images and each have the true labels. So from that we are going to predict the test performance of our model. Then after, we have to make sure the evaluation results using the confusion matrix. So this diagonal is the true ones, and others represent something wrong. So the training directory, from the training directory, we have from training data, and from the testing results, we have to evaluate the confusion matrix. So the confusion matrix, when we move into this picture elaborations, we can get very clear what clearly we can visualize the result. The shine is predicted as shine as correctly 1, and sunrise corrected as 6. So it's very good result. And cloudy corrected as 6, and foggy almost it corrected as the 7. So this confusion matrix shows the results. And other than the confusion matrix, there is another one we can create it for the evaluation results, that is rock curve. So with a different awk value, we have created the rock curve for the classes, 5 classes, and we labeled it as 0, 1, 2, 3, 4, and we can observe the rock curve and for this training testing performance of this model. So this is the brief idea of this classifications for the weather data sets. Almost we able to get the accuracy of 76 to 80% of the accuracy. Sometimes if we do some any other experiments or hyperparameter tuning or any other data augmentations, data pre-processing, there are some other techniques we can use to improve the accuracy of the CNN model. So until now, what I am doing with the experiments and hyperparameter tunings and all other stuff such data augmentations, I am able to get the accuracy, the 76 to 80%. So that's it about this model. That's it. Thank you.